Here's problem 2-66. It says, write a possible exponential function in y equals a times b to the x form for each graph described below. For letter A, it has a y-intercept at 0, 3 and passes through 2, 48. For B, it says it passes through the points 0, 2 and 3, 0.25. So I wrote it down on a separate paper. So I'm supposed to get one of these. So I don't know if you remember this from integrated 2 or integrated 1, but A is always the starting point of your exponential, and it's the y-intercept, and B is the multiplier. It's like how fast it's growing. So really, that number right there, that's going to be A. But if that's not super obvious to you, then you can just plug in x and y. So if you plug in x here, you'd have b to the 0, which is 1. And you'd have y is 3. Should we do that real quick? We'll just show it. So I normally wouldn't go through this part, but you can just plug in for 3, or for y, you can plug in 3. And then a times b to the 0. Well, we know b to the 0 is 1. Let me write that up here. B to the 0 equals 1. Anything raised to the 0 power is 1. So that means that A equals 3. Okay, we know A equals 3. So then what we're going to do with that is we're going to rewrite our exponential equation and use these two numbers to help us get B. So I'm just rewriting this. So I'll start it like this. Y equals A times B to the X. Okay, so I know A is 3. So I got Y equals 3 times B to the X. Okay, and then I'm going to take an X and a Y, plug them in, and solve for B. So here's a Y. The Y is 48. And the X is 2. Okay, and then I'm just going to do my algebra. So I'm going to divide both sides by 3. And why do I think 16 times 3 is 48? I'm going to take a chance and say I think 16. So if 16 is b squared and I square root both sides, then b is going to equal 4. So now I know A and I know B. So I can write Y equals 3 times 4 to the X. Okay, that's what I want to do for this problem. And then for the next problem, it's the same thing. I can just look at this and I know that this is, here's an X and here's a Y. I know that's the y-intercept. I know that that's A. And if I didn't know that, I could just do this process over here. But I already know it's A. So I'm going to say y equals 2 times b to the x. Then I'm going to use this x and y to solve. So this is 0.25. I could write it as 1/4 if I wanted to. I think I will, because I love fractions. Okay, I'm going to divide both sides by 2. I could divide both sides by 2, or I could multiply both sides by a half, which is the same thing. So I'm going to multiply both sides by a half. That makes this go away. Now I've got 1/8, or if you did decimals, I think it would be like 0.125. Okay, and then I'm going to cube root both sides, because this is cubed. So I'm not going to square root it, I'm going to cubed root it. Okay, so I can think of it as the cube root of 1 is 1, and the cube root of 8 is 2. And so there's B. So I have B, and I found out, I know A was, I got the A right from here. a equals 2. So then I can just write it all out. Y equals a, which is 2, times b to the x. Let's write it in parentheses. And don't get tempted. You can't multiply those together and make it be 1 to the x, because this exponent is working on this base, and the order of operations won't allow you to multiply these together. You have to leave these alone. That's a, that's b, and that's x, so that it's in the proper form.